Thank you for that very nice introduction. That's the first time that I've been called the best speaker on web security in the vote of 1. So that's very, very nice of that person who recommended me. So I'm happy to be here. I was happy to be here last year, and I'm happy to be back here this year again to kick off sec4dev with the opening keynote. So I'm really, really excited to see so many people here. We have plenty of space. We have a nice room. So it should be a very fun 2 days. For some of you, it's a third day. You've been here 2 days for the workshops, the boot camps as well. So enjoy the rest of the conference, I would say. In this keynote, I would like to come back to what Thomas said in the introduction, that sec4dev is about security for developers. It's not about security for security people. It's not about the most advanced exploits you can find today. It's about how you can build secure applications. And honestly, we didn't really discuss this up front. It just works out very nicely because that's the nature of the conference, and this is awesome. And I've been doing security for developers for a long time, and I've seen a lot of problems that developers face. And in this keynote, I want to talk about 2 specific things, actually. I want to talk about our stance against security, how we handle security, how we think about security, how we can probably do better there. But I also want to give you some concrete guidelines based on actual cases of what can go wrong and how can we do this better. And we've been talking about this at speakers' dinner yesterday, and we had a lot of fun, so I'm kind of hoping you will have some fun here as well. It's totally okay to laugh throughout the talk, or to cry sometimes, that's fine as well. Or if you're an introvert like me, just sit there silently, don't look around, that's also fine. Whatever suits you, basically. There's a room full of practitioners, developers, operations, security people. There's probably a few security people here as well. AppSec, ProdSec, whatever. Maybe a few managers, and that's awesome. The real awesome thing is that you are here for 2 days, which means that you're investing 2 days of your time to come learn about security. And that tells me one important thing. That tells me that you take your job seriously. Because honestly, we've all been on these seats probably. It's not fun to sit on a wooden bench for 2 days straight. So you need to be committed to do that. You need to be willing to learn. And I'm also pretty sure that all of you have felt underappreciated at some time in your job. It's hard to get security right because security causes this friction. People think about like, oh no, security gets in the way. Or why do I have to do this? Or is this really a problem? And you have to fight. And sometimes you want to do the right thing and your boss is like, do we need that? No, you don't need that. Just don't spend time on that. And you're like, but it's the right thing to do. And you're in a world of trouble if you try to get it right. And that's a constant struggle. And that's something that you face. And that's something that I see in every one of my customers' companies as well. Developers, especially in the training, we get to know each other over 2 days. And they start telling stories like, yeah, you know what? We're not allowed to do this or that internally. And they struggle with that. They have a problem with that. And if you keep this up, if you keep nurturing that culture in your company, it's going to grow worse and worse until you're at the front page of the newspaper for this Austrian company or whatever you're working for, having serious security problems. And trust me, that's not where you want to be, because if you're there, you're going to be in the talk I'm going to give next year. I can promise you that. We're going to talk about a couple of cases here, and you'll quickly get an idea of what I'm talking about. First thing I want to talk about is Facebook. Facebook, apparently, this is a story from last year, from Brian Krebs. Facebook has been storing millions of users' passwords in plain text. It's like, what? And I see some confused people like, whoa, that's not good. And you're right, this is really not good. This was a big story. And whenever a big story like this breaks, typically it draws out the people on social media. You'll find people like this gentleman saying like, whoa, that doesn't surprise me at all, of course. I mean, Facebook, they suck. Really? How is this possible? Or you'll find people like this with a very useful contribution like, oh, of course, even the best have lazy developers. Wow. Ask yourself, if you ever feel the need to tweet something like this, what does this add to the conversation? What does this do except make yourself maybe feel a bit better about your crappy security if Facebook also does it? Nothing. And what does this do for the people working at Facebook? I know people working at Facebook. They're actually smart people trying to get things right. Do you think they like seeing stuff like this? They're fighting in the trenches like yourself every day, and then people are like, oh, of course, they're idiots. They don't know what they're doing. Honestly, this makes no sense to me at all. And it's something you should think about when you talk about these things. And the real problem I have with this here is that these people can't seem to engage in any form of critical thinking. If there's an article saying that Facebook stores millions of passwords in plain text, you should think about what that means. Like, does that make sense? Maybe your first reaction is to laugh at that. I saw a few people like, ha, ha, ha. Facebook, hi, no, not good. And that's okay. That first reaction is what we all have. I have the same thing. Sometimes you read a story and you're like, oh, come on, what the hell is this? How is that possible? But you need to keep thinking further, because usually it's not that simple. Usually there's a lot more going on, or the story is very misleading, as it is in this case. And that's something that I read. I sometimes read Reddit right before bed because it helps me relax. And there was a comment on one of the posts that actually hit me, and that said that these first reactions, we have that all the time for everything. In security, but just as well in regular life. If you see something weird, it's like, oh, what the hell, that's weird. And that first reaction is what we have been taught to think, how we've been raised. Like, oh, you have to think that this is not normal, and you have this reaction. But the moment after that, usually most people start thinking this through and like, oh, but this is actually kind of okay, and yeah, that's good for them. And oh, sounds weird. Is it really what's going on? And that critical thinking process is crucial. That is what defines who you really are, how you really think about things. Not the first reaction. You have to step past that and think about what this really means. And for me, the first reaction when I saw that story was like, whoa, that doesn't make sense. Because I actually read about how Facebook handles passwords a couple of years ago. They call it the password onion at Facebook because they have layers of algorithms that they apply on passwords. And the second thing that doesn't make sense is that Twitter had the same problem. Like, huh. And Github had the same problem. The difference is that for Twitter and Github, there wasn't such a backlash. Apparently, people really hate Facebook, even though they spend every free minute they have on that website. That's kind of a disconnect there. So if you see stories like this, what the hell is really going on? Because these companies actually do know better. They know how to handle data in a safe way. And I can tell you that they don't store passwords in plain text in the database. So you have to dig deeper. And that's why the other articles are better than the first one, because the Facebook article, in my opinion, is intentionally misleading. And Brian Krebs is a very respected investigative journalist. He does great work, and I honestly expected better from him, because you have to go through the article and read between the lines to find out what really happened. And what really happened was something like this. You have a user on Facebook trying to log in or reset a password. I don't know exactly which flow it was. And it's going to send a request to a backend. It's going to pass through a gateway somewhere. This is a really simplified architecture. This is not how we actually build Facebook, but you get the idea. It's going to end up at a backend, which is going to verify that against the database with proper password hashing and so on and so on. And what really happens is when you submit that, is that there's a request going out, a post request. To the login form, to a password reset form, whatever is being used here. And what's one of the best practices for security? Logging and monitoring. So what happens here is that that request actually gets logged by one of the systems. Like, hey, we got a post request, this was the content type, these are the parameters, whatever. I just made something up, but every logging system has their own format, whatever works for your systems. And that is what's going on here. A lot more nuanced than Facebook storing millions of passwords in plain text. It's a bug in their logging system. And this ends up in a log, and employees had the ability to search the logs for potential problems or bugs or whatever, and debug an issue and move on and fix the product. And that's the same thing that Twitter and Github had. That's a whole different story. So always think about what's going on. And at this moment, I would like to reflect on this for a second. I would like to make a confession. I did a workshop the past days, and for my lab sessions, I use a custom-built training application. It's a training application built with Spring, Java Spring, Boot, awesome framework, and I do request logging. And if I would handle authentication in my application, I can tell you that I would have had the same problem in my application. I did not think about the fact that sensitive fields can end up in logs, and passwords are really sensitive. Plain text submitted to the server over HTTPS, of course. Of course, well, of course no. Fortunately, I know how difficult it is to implement authentication, so I didn't do that myself. I offloaded that to Auth0, a cloud-based identity provider, so they handle passwords and usernames and all of that for me. I don't have to worry about that. That's OpenID Connect, really awesome if you want to achieve that. But that tells you that these bugs are easy to implement or easy to create. You just have to enable logging. Maybe you don't even do it yourself. Maybe a colleague does that. When they finally deploy the application, and all of a sudden you have this vulnerability. And I'm pretty sure, there's a reason I'm talking about this, because I'm pretty sure that some of you in the room will have a similar problem. And passwords are an easy case. You never need to store the password in a log, so just kick it out. But what if you have other sensitive data? What if you're building an e-health application, a financial application? You might want to log a lot of information for debugging purposes, but you might not want to log that in plain text. And if you think that plain text is fine, you should probably talk to your DPO in your organization, because the GDPR is probably going to disagree very much about storing a lot of plain text information in logs. And that makes this a much more nuanced and complicated problem. All right. My advice, go look in your application for exactly this problem and then fix it. So how do you fix it? Well, I have a rough idea how to fix it. You probably have a way to filter out certain fields, a way to filter out certain values. So with that idea, I went to work, and I went to Stack Overflow. And of course, well, actually I used DuckDuckGo to go to Stack Overflow, and of course on Stack Overflow, you'll find the right answer, as usual. So you can find the message here. This is for Logback, a Java-based logging engine, and you can define a pattern that it looks for and a pattern that it replaces a value with. So by configuring your logging system, you can tell it like, oh, you know, this password field, that's actually really sensitive. You shouldn't log that, so let's just replace it with XXX or whatever is maybe a bit more appropriate for your log files. Whatever works for you. And of course, if you want to do advanced logging, just pattern replacing is not going to cut it in the end. So you might need a more advanced system as well. But this is an initial step to get you going. It's an easy fix, but you have to think about that. And the secret to security is always, it's often not that complicated, but you have to think about it. If you haven't thought of it, you have a problem. And that's often what you can boil down security issues to. So let me give you a first takeaway. Not the code. I have no idea what the code is. I just took that from Unsplash, an awesome website with free pictures. So if you find something offensive in the code, please tell me. I'll replace the slide. The text here is what matters, the white text. What I want you to do, probably Monday, I'm realistic in that. What I want you to do on Monday is analyze your application for this exact problem. Logging requests, what fields are sensitive, what should we not be logging? It's not going to be an easy task because you'll have to figure out for every request what is being sent. Hopefully you have good API documentation that's going to help you quite a bit to figure that out, but that's something you have to do the work for. Then make sure that these fields are not present in the logs anymore. That's the next step. And then finally, if you have found fields that were being logged that shouldn't have been logged, go to your log files and take them out. Inform your DPO if it's really sensitive, because you might need to communicate that to customers one way or another. What Facebook, GitHub, and Twitter also had to do because they logged passwords. All right. This was like the warming up, getting started here, where either you're hooked now or you're tuned out, but either way, I'm going to continue. So hopefully everybody is following along so we can talk about Equifax. Who here has not heard of Equifax before? Wow, okay. I did not expect that. You are in for the most wonderful story of a lifetime. How do I put this correctly? Let me think about it. Equifax is probably the most incompetent and unethical company doing anything cybersecurity related. Yeah, I think that nails it. So that's the baseline. Yeah, I don't think I'm ever going to work for Equifax at this point. So let's say that goodbye to that one. So Equifax is a US-based company. They offer credit report services. Basically, they have a huge database of how well you are doing financially, and if somebody wants to give you a loan, they can go to Equifax and ask, like, should we give this person a loan? And based on your credit score, they will either be like, better not, or go ahead. That's essentially in a nutshell what they do. They have a lot of sensitive data. Your personal information, your social security, well, not your, but if you're an American, your social security number, your parents' information, things like your mother's maiden name, which is used to fill out security questions, and all of that, sitting in a very nice database on that system. Equifax, of course, they have applications using that data, and they build their applications with Apache Struts too. By itself, not a problem. Maybe a bit of an older framework. Spring and Spring Boot are much cooler, and all the young kids are doing that, but Apache Struts is a solid choice for enterprise applications. It's used a lot. By itself, no biggie. This is a story from 2017, by the way. In March 2017, March 7 to be exact, the Struts 2 team released a patch, along with a press release saying, like, you know what? We have this really nasty secure remote code execution vulnerability. We fixed it, so please install this updated version. Awesome. The whole world was like, holy crap, let's start patching. This is a bad one, like as bad as they get. Basically, with one single request, the attacker could execute arbitrary commands on your server. That's a problem. All right. What do attackers do when something like this hits the news? They're like, ooh, a new version. They're going to take the old version and a new version, and they're going to diff that versions. And out comes like maybe a few thousand lines of code. That's the changes. And they're going to be like, so what did you change to fix this vulnerability? And they're going to figure out what changed, what the problem was, and how to exploit that. And once you have that, the world is your oyster as an attacker. You can go wherever you want, from system to system, like Equifax. Look at the date here, March 10. 72 hours after the press release hitting the web, the attackers were in Equifax servers. That is impressive. That's a lot of overtime to build that exploit and use it. 72 hours, like, hey, there's a problem, bam, we're in your server. And they started poking around and looking at, what do we have here? Like, oh, we have an interesting database, and so on and so on. And Equifax was like, all good, nothing happening. May 2017, 2 months later, the attackers were like, okay, we have a pretty good handle of what's going on here. You know what? Let's start grabbing some data. And they start data exfiltration. Massive amounts of data exfiltration. And Equifax is like, all good, nothing happening. Until July. In July 2017, another 2 months later, Equifax is like, oh, that's not good. And they discovered the data leaving their network. At that moment, they were like, oh, crap. And they started addressing that issue. They started investigating, hired a firm to do forensics and all of the things that they should be doing. And in September, they announced that they got breached and that they lost about 147 million people's data. 147 million. That's was one of the biggest data breaches back then in 2017. That's a lot of personal information being stolen. It took 6 months from the first breach to the announcement of the breach. And it took at least 4 months to patch it. That's the Equifax story. What makes this the most unethical company? Well, in between this period here, July and September, some C-level executives sold a lot of stocks from Equifax. Not the best way to do it. This is called insider trading, if you're trading stocks based on information that you know, and some people actually went to jail over it, which is surprising. In most cases, nothing happens, but here, they didn't think this was very funny, and they actually prosecuted them. All right, so this all happened. The announcement here, September 7, that was a Thursday. Not the best Thursday for a lot of people whose data was now exposed. By the way, the data never surfaced We don't know who has it. Somebody has it, but it never became public. So guesses about what's happening with that. Anyway, this was a Thursday. And on Friday, one day later, Equifax support tweets the following. That is some dark humor. People were not very amused with this. They got obliterated on Twitter. Like, first you announce that all our data is up for grabs and we have no way to protect us and all of that. And now you're saying, Happy Friday? Like, no, that doesn't work very well. The tweet is not there anymore, so not the best way to handle a case like that. Probably not that person's fault. They probably didn't know about this when they came to work in the morning or whatever. But still. 2 weeks or 3 weeks later, the former Equifax CEO gave an interview and basically said that it was all John's fault. John was supposed to install the patch and he didn't, so yeah, that is the problem there. It's like, what? Seriously, I have no idea what's going on. Well, actually, I have a bit of an idea what's going on at this company, but this is not the way you handle security. You don't blame one person not installing a patch. First of all, I don't buy that story. And second of all, even if it's true, that's not how you defend yourself from being breached. I don't buy this story because it's usually a lot more complicated. The good thing about Equifax, and this is absolutely awesome, is that they are very publicly known. The government in the US has contracts with them, and the government doesn't take this lightly. So what they did is they started an investigative committee. They actually looked into Equifax and started asking questions like, why the hell was this allowed to happen? They published all of that in a report. You can go to Google, download the PDF, and you're going to have a fun document to read during the weekends. You probably need a drink with that document. Otherwise, it's not going to be very fun. So what are some of the takeaways here? I actually read the document. Well, I skimmed through it to the interesting parts. Apparently, in 2015, Equifax already had an audit that indicated that their patching process was insufficient and inadequate. There's a full-page table in the report saying like, hey, this is a problem, and that should be the solution, and this is a problem, and that's a solution, and so on and so on. And it had deadlines to remediate all of these issues. And those deadlines were all in 2016, a year before the breach happened. And guess how many of those issues got remediated? 0. But yeah, it's all John's fault because he did not install that patch. All right. The interview with the executive. So they had to appear before this committee, they were interviewed, and they asked, like, what's your patching process? Like, oh yeah, we have system owners and application owners, and they're supposed to install the patch. Like, oh yeah, that kind of makes sense in like a big organization, sure. Then they asked, like, who is the application owner for this application that got breached? And they're like, yeah, we don't really have a list of application owners, so I think it's probably that person or that person. It's like, okay. And then they asked, like, who was a system owner for this? Yeah, I don't know, but if I had to guess, it's probably one of the people working under this person. It's like, what the hell are you doing? How does this work? And I know I'm making fun of them, but I'm pointing out the hypocrisy of a CEO telling that it's one engineer's fault for not installing a patch. This is a leadership failure. By the way, they have an email system. The report is full of actual details. It's awesome. They have a mailing list for patching. So what happens is when a critical patch comes in, they send out an email to all application owners. And they have a list of some sort. They send an email out to about 400 people. This patch needs to be installed. Good. That's an initial kickoff. And then they asked, like, how was this followed up? Like, was there a follow-up meeting to make sure this happened and so on and so on? And it's like, yeah, it got mentioned at a staff briefing a couple of days later. There was like a PowerPoint slide about this. That's it. Like one mention in one staff briefing on one slide. Like, oh yeah, by the way, there's this Struts thingy that you should probably patch. Again, not how you handle patching. You need to. This is a critical vulnerability. This is not. It's not a small bug about a button being in pixel too far to the left. No, this is a freaking critical remote code execution problem. You follow that shit up closely. if you know what you're doing. All right. I'm going to keep with this. This is really, really interesting stuff here. The report goes further. They state that Equifax CEO did not prioritize cybersecurity. My initial response was like, no shit, Sherlock. But the next comments are actually much more interesting. They interviewed a CIO, and he testified that there were quarterly meetings at the C-level, senior meetings. And security was one of the topics discussed at those meetings. Like one of the bullet points, like, how are we doing financially? Did we make enough profit? Like, oh, by the way, security, all good? Like, yeah, we're good. Again, not the best way. And the worst thing is that the CEO in these meetings got his information from the head of the legal department. Because the chief security officer, she wasn't even present in those meetings. She wasn't high enough on the ladder to be present in the senior executive meetings. So they did have no real information about their security, except from the head lawyer, like, yeah, we're all good. Nobody's going to sue us. Well, that turned out differently, but this is, to me, this is unbelievable. I don't get it. And if you have something like this, you still have the nerve to blame John for not installing that patch? That does not compute. One more slide on the report. It turns out that Equifax wasn't totally clueless. They actually spent a lot of money on network monitoring devices. Awesome. They bought a device that can inspect network traffic, and whenever it sees your data leaving, it's going to be like, hold on, not cool. And you'll get an alert, and you can follow up on that. But their devices didn't work. Well, we kind of got that from the whole breach, but it didn't work. So that's kind of weird, right? So why do you have it and it doesn't work? Well, it turns out that this network inspection device needs to man-in-the-middle HTTPS, which is normal in these settings, but their certificate for that device expired. That's not a good thing to have. And you know what? It expired 19 months before the breach happened. I kid you not. This report is a goldmine. Seriously, if you're doing any policy in your company, this report is a goldmine of what not to do. Just map it to your policy, and if you have the same thing in your policy, no, out. We need to do something else. Seriously, how does this happen? I don't get this. Well, I get it. It's a company that doesn't pay any attention to security, that doesn't instigate a security culture. This is ridiculous. And you know how they did discover the breach? Because someone updated that certificate, and within 5 minutes, the system was like, hold on, here's a problem. And they found the data leaving the network. These systems work if you have them set up correctly, if you test them. Send some data out of your network to one of your own servers, not to an attacker, and see if the system finds it. And the report goes deeper. They're like, oh, but is this like a systemic problem? And they found that Equifax had about 324 expired certificates at the time. And 97 of those certificates were used on systems to monitor critical servers. All of those systems were out of service because of these expired certificates. That's not a problem we're supposed to be having in 2017 or today for that matter. Seriously, look for the report online. You'll easily find it and give it a read. There's a lot of valuable lessons in here. A few things I want to take away. Security, you can try to blame it on John for not installing the patch, but it doesn't work like that. If you don't put security on the top of your priorities as a company, from the higher levels up, it's not going to work. It doesn't work like that. You cannot expect engineers to just figure it out and do it because it takes a lot of time, it takes a lot of investment, and if they don't get that time, it's not going to work. You need buy-in from the top. The most effective trainings I do are the trainings where somebody from the management introduces me, like the CEO coming down to the training room, like, hey, we brought 20 people here together for training. This is really important. We want you to invest. The serious companies asked me to sign an NDA so developers can actually talk about their systems with me without risking me tweeting all about it, which I always do, of course, when I don't sign an NDA. But these are really important. Sometimes managers are even in the room with the people learning, exposing themselves like, hey, I didn't know that. I don't know how to do this lab session. And they learn on the spot, and that sends us a really powerful message. Think about that. And focus on building the right security culture. All right. And the final topic, I have 6.5 minutes left. I want to talk about the 97%. Over 97% of your applications today are dependencies. We all know this. Building a Spring application, guess what? You're pulling in Spring Boot or the Spring Framework and Spring Security and Spring Cloud and Spring Data and bam, bam, bam. 97%. And I know that the number 97 is like, ooh, that's a big number. But it doesn't mean much. So what I did is I ran ng new on a clean Angular application. And it asks you some questions like, hey, you're building an Angular app. Do you want routing, like different routes? Like, yeah, I do want routing. And do you want some CSS stuff? Like, yeah, fancy Sass, please. And it's going to install a bunch of packages. And at that moment, you have 1,169 packages in your application. All right. Interesting. You also have 1,030 contributors. Awesome. So that's a lot of packages, but what does that mean code-wise? Well, if you install one more, you can actually count the lines of code. So install a new package, and now you have one package extra, and you can start counting lines of code. And the lines of code in this Angular application consist of all kinds of code, but in the end, you have 2,336,228 lines of code. You, as a developer, wrote 0 lines of code, yet your application has 2 million lines of code. That's the reality that we live in. This is for Angular. The same goes for React, and the same goes for backend applications on Node.js and Java and .NET and all of these things. That is the world we live in today. You have thousands of developers working for your company. You just don't pay some of them. That's a different story. You also have 1,030 contributors. That's a lot of people adding code to your application. And by itself, this is awesome. A framework like Angular allows you to build really good applications. Absolutely amazing time to be alive in. The downside is that managing this system is tricky. Because 78% of vulnerabilities in an application exist in dependencies, in indirect dependencies. That means you include Angular, and Angular includes this library, and that library has a vulnerability. You now have a vulnerability in your application. 0 lines of code, maybe 20 vulnerabilities. That's how these ecosystems work. And that's something to keep in mind. So what do you do to fix that? What do you do to learn about these vulnerabilities and to fix them? By the way, Equifax's problem was a dependency as well. So what do you do here? Well, there's a tool built into NPM called NPM Audit. And NPM Audit will tell you like, hey, you know what? In your package list, we found a few problems. In your application, you have 20 vulnerabilities. Oh, crap. This is over a period of like 2 months' time. I kid you not. That many problems being discovered in libraries and being patched. Not malicious, intentionally malicious pieces of code, but just a mistake in a dependency. And now you can fix it by running npm audit fix, and it will update version numbers, and you're typically good to go. Usually it's a very easy update process. Where do you run this? In your CI/CD pipeline, right? Who's running this in their pipeline? All right. How often do you build your application? 10 times a day. Awesome. So you'll get an update on this 10 times a day. That's great. How often do you build your application on a Sunday? Once a day. Awesome. What about Christmas holidays? That's good. Many people start thinking, well, many companies are doing that. And then they start like, oh, we don't really build it like once a day. Especially after a while, if the application is older and it just works, then it's sitting around and maybe every month somebody takes a look at it, but it's not built continuously. And given the Equifax story, the recommendation today is you have 24 hours to patch a critical vulnerability. If it gets released today at 9 and you build tomorrow at 8 o'clock, you have 1 hour to push out a patch, roughly speaking, because in 3 days' time, they are in your application. So this is good, but not good enough. You need continuous monitoring. And GitHub offers this as a free service, and vendors offer this as a paid service. And they will continuously monitor your package file and a database of vulnerabilities and cross-match them. And if one of these gets updated, they will match again, and they will send you an update. And that is really, really important. The takeaways here are, keep your application up to date so you can apply patches quickly. Seriously, if you're still running an Angular 4 application and they announce a vulnerability in Angular and you have to first update 3 major versions before you can apply the patch, that's going to be a rough week. Keep it up to date. Even legacy applications need to be kept up to date. You need to have a fast security release process. One of my customers, I asked them, how fast can you release an app? Like, yeah, if we're lucky, it takes about 3 weeks from publishing it to production. It's like, not good enough. I understand they have a QA process that goes through rigorous testing, and that's good for feature releases. But security releases should be swift, should never add new features, and should be swift out the door. And test this process. It's all good to have it on paper like Equifax has, but you need to test this. Take a non-critical vulnerability, take a test case, and make sure you get those patches published within a day. That is what you have to aim for. All right. I have like 1 minute left, so in a final note, I'm going to skip a couple of slides, but I want to tell you this. Even though you're using open source software, which is perfectly fine as a company, that's the deal with open source, it's available for you to use according to its license terms. You do not own the developers of that package. There's a lot of abuse against open source developers of companies making demands when a vulnerability occurs, like, why is this there, and fix it for me, and do this and do that, but you're not entitled to that behavior. Open source developers actually suffer from that, and there's a bunch of cases where people have to deal with a lot of crap that they shouldn't have been dealing with in the first place. And with that, I want to ask you to behave in a bit more of a respectful manner. I want to ask you to think about the people on the other side of the coin. The moment you want to bitch about a company getting something wrong, think about who you're targeting here. Because often it's somebody like yourself working in the trenches, trying to do the best they can with the tools they have, with the time they have, with the mechanisms they have, the money, the budget. And it's not always that easy. It's not always that simple to get it right. And if you talk to real people, to real companies, you'll hear the real stories instead of what you read in the press, and it's a lot more nuanced, and it's a lot more difficult than you might think. And sec4dev is the right place to learn how to do that, allowing you to bring that knowledge back to your company and to start cultivating that security culture. All right. Thank you for listening, and I'll see you around at the conference for the rest of the 2 days.
Takes some seconds. Yeah, there you go. Thank you, Philippe, for this very inspiring talk and keynote. We have a couple of questions from the audience. I'm going to start with a very simple question.
Awesome.
Somebody is asking, are you a hacker?
No, I am not. I know about security, but I'm not a hacker in the sense that I don't have the patience to try payload after payload until it finally works. That's not what I do. What I do is I explain how security works to builders. So I'm more of a defender than a hacker. I try to explain how security works, what best practices to apply, or what trade-offs to make when you build secure applications. That's what we did in the workshop. We didn't really hack things. We had textbook offensive examples and then focused on the defenses, how you actually build a more secure application. That's what I do.
And that's why your work is a 100% fit with sec4dev, exactly for that reason.
Another question is, what can we do to get away from the shame and blame game? Isn't this something inherently human?
Change human nature. Easy. Honestly, the reason I wanted to talk about these things is because it frustrates me for a while now. So people always bitch and complain about Twitter like, oh my God, look at these idiots and this application screws that up. And even the most popular accounts, they get popular because they do that. And I think what really works is try to give a different perspective. Try to think about lessons learned. I also tweet about issues. If I find tweets from me, you'll see that I tweet about, hey, this went wrong there. And I try to attach a lesson learned or a different perspective or something like that. And I think if we try to do that as a community, if you inspire others to do that as well, then we might be able to move in the right direction. And within one company, blaming never works. Blaming John for not installing the patch, that's not the right way, because we all make mistakes. I make mistakes. That's human nature. So instead of blaming, try to learn what went wrong, how can we build better guidelines, better libraries to prevent this from happening in the future. Because in the end, the whole company is in the same boat. It's not one team against the other. Oh, those guys screwed up, but we can do better. Yes, competition is good, but in the end, you're all responsible for the entire application portfolio of the company. That's what it comes down to.
Do you know if there were any legal changes after the Equifax breach? So did laws change because of that? Are you aware of any of those?
Directly, no, not that I know of. So a lot of things happened in the Equifax breach after that. I think one of the most important changes might be that, well, the GDPR in Europe was coming, so that was related to that somewhat, because it forces to take security seriously as well. And California is moving in the same direction. But whether it's directly related, I don't think so. But the combination of all these data breaches together definitely results in laws getting stricter. And that's hopefully going to be a mechanism to force companies to do better, even though that might be debatable as well. So we'll see how that goes.
A question about Equifax. So when did they actually patch the system? Do you know that?
I'm kind of guessing after they discovered the breach, but I would have to look up in the report when they actually patched it. But it was still unpatched in July, so not that quickly, no. But by the way, even if you patch it after the first exploit has happened, the patch is going to be ineffective because the attacker will have a backdoor to get into the server anyway. So once they're in, or once you patch after the breach happens, you'll actually have to investigate whether you're breached, and that's going to be very hard. So yeah, it's a difficult problem to solve, I agree.
There were two more questions of organizational nature. So are the slides going to be available? So yes, they will be available after.
If you go to my Twitter feed, you can find the slides. I should have tweeted them out like an hour ago. Even if you don't have Twitter, it's public, so you can just go to Twitter without logging in and get that tweet with the PDF of the slides as well. And on my website, you can find the slides too, and I'll provide them with the organizers as well.
Yes, slides and video are going to be available of almost all the talks, not all of them, but this one is going to be available as a video as well.
All right.
Thank you very much, Philippe de Ryck.
You're very welcome.